So next we're going to practice with writing our hypothesis, identifying our variables, our control group, and some conclusions. So I'm going to do the first one with you, and then I'm going to suggest that you pause the video and try some of the rest of them on your own. So here's our first scenario. Mary Jo is a local baker in Fieldsville. For years, she's owned and operated the bake shop, Mary's Sweetness. Chocolate chip cookies are the bake shop's best seller. For the last 15 years, she's sold an average of 350 chocolate chip cookies per week. However, in the last 4 months, the sales of chocolate chip cookies have drastically dropped. Mary believes this is because customers want sweeter cookies. Mary decided to sell 3 different chocolate chip cookie recipes. The only thing she changed in the cookies was the amount of sugar that she used in each batch. She made the original, her standard batch, which contains 2 cups of sugar, the new sweeter batch, which had 2.5 cups of sugar, and the new to die for batch, which had 3 cups of sugar. She did this for 6 weeks, and below are her sales after the 6 weeks. So the first thing we need to do is we need to come up with a hypothesis. Now remember, this has to be an if, then, because format. So the if part is, what is Mary Jo changing? So if I change, or Mary Jo changes, the amount of sugar in the cookies, that's what she's changing. The then part is her prediction. So remember, she thinks that the customers want more sugar. So I'm gonna look at the things she changed, and I'm gonna see she's got 2 cups of sugar, 2.5 cups of sugar, and 3 cups of sugar. So since Mary Jo thinks that they want very sweet cookies, I'm gonna predict that then the to die for batch, the batch with 3 cups of sugar, is going to sell the greatest. And why do I think that? My because portion. The because part is because Mary Jo thinks that the customers want sweeter cookies. So if Mary Jo makes cookies with different amounts of sugar, then the cookies with the most sugar, which is the to die for batch that contains 3 cups of sugar, will sell the greatest because Mary Jo thinks that the customers want sweeter cookies. Now, what is Mary Jo changing? Her independent variable is the amount of sugar that are in the different batches. 2 cups, 2.5 cups, or 3 cups of sugar. What is she going to collect data on? Her dependent variable is going to be the number of cookies she sells. Her control group, she's going to still sell the original batch. So she needs to be able to compare what normally she made to the experimental group. So the control group is the group that's not getting any changes, and the experimental group are the batches of cookies that have the different amounts of sugar. So the control group is her normal. And then the results and conclusions. So we've got to look at her data, and we've got to see, okay, which group of cookies was really selling the most? And if you look through the data, the middle ground batch, the sweeter batch, looks like it was selling significantly more. And actually, it looks like the most sugar group, the to die for batch, actually didn't do so well. So really, her conclusion should be that her customers want a little more sugar, but not a lot more sugar. So now I would like you to pause the video, and then you can come back and I will walk through each of the different examples. The first one, you've got Rodney, and then there's a few other examples for you to practice and then check your answers with me. Okay, so next we have Rodney, where he's got flies coming in and he can't seem to be able to catch and trap them. So that's his problem. What material is going to capture and trap the flies the best? And so he's going to use bread, watermelon, a banana, and then of course he's got his control. The no food. You can see that in the graph there. So the problem is, what is going to catch the flies the best? What material is going to catch the flies the best? So the hypothesis. Don't look at your data when you're doing the hypothesis, because you're not always going to have data. The if part. What are you changing? If Rodney uses different materials to trap the flies, bread, watermelon, and a banana. So that's what he's changing. Then, which material do you think is going to trap the flies the best? I'm actually going to predict that the banana. Then the banana is going to trap the flies the best, and then my because part is my why. And I think that because bananas are very sweet and they're sticky and they kind of start to rot and turn brown really quickly, so I think that flies are going to be attracted to the banana. So my hypothesis, if Rodney uses bread, watermelon, and banana to try and capture the flies, then the banana is going to capture the most flies and attract the most flies because the banana starts to rot and smells very sweet and has lots of sugar to attract the flies. Now my control group, remember we always want to compare our experiment to something that's the norm. So if we have no food, that would be my control. That is not changing anything. Then I've got my data that I collect, my dependent variable. Now, something you can start to recognize is that the data is going to go on the y-axis. So we can see that the dependent variable is the number of flies that were attracted to these different foods. The independent variable is what is it that Rodney is changing. So Rodney is changing the food. Is it the bread, is it the watermelon, or is it the banana that's going to attract the flies the most? So the independent variable, again, is what the scientist changed, and he changed the different types of bait. And that usually is going to go on the x-axis. So that's something else that you can start to recognize if you've got a graph, or when you're building a graph, something to recognize. In this next example, we can see the problem in the very first sentences. Scientists believe that acid rain may cause frogs to become more prone to disease and die. So the question, the problem for the experiment is, does acid rain cause the frogs to be more prone to disease and die? So the hypothesis, if part, what are you changing? So we can see that we've got group A and we've got group B and we've got group C. And each of the groups are being exposed to different amounts of acid rain. So if the frogs are exposed to different amounts of acid rain, then what do I think is going to happen? Then the frogs exposed to the highest amount of acid rain are going to be more prone to disease and dying. Why do I think that? Because acid rain is damaging to organisms. It's harmful to them, it hurts them. Hopefully you have a little bit of background that acid rain is not a good thing. So again, my hypothesis, if the frogs are exposed to different amounts of acid rain, then the frogs exposed to the most amount of acid rain are going to be more prone to disease and die because acid rain is not good for organisms and is harmful. Now, the independent variable. Remember, the independent variable is what's being changed. So group A is going to be exposed to no acid rain. So group A is actually going to be my control. My independent variable is 0.2 centimeters of acid rain and then 0.6 centimeters of acid rain. So the different amounts of acid rain that group B and group C are exposed to. The data I'm going to collect. I'm going to record how many of the frogs are going to get diseases or are going to die. My control is the group that's not getting any sort of acid rain. So that's going to be group A. And the result, if I look at my data, it says that group A did not have any frogs with disease and group A were not exposed to any acid rain. So I can say that group A, being exposed to no acid rain, had no disease and did not die. And group B and group C did have disease and problems. And so that means that acid rain is going to make them more prone to disease and die. I do want to use data. I want to say group B had 13 frogs and group C had 45 frogs. And I want to then point out that the group A having no disease, group B having a little bit of acid rain and 13 frogs with the disease, and then group C, the most amount of acid rain, had the most disease. So therefore I can conclude that the acid rain did have an impact on that disease. Now on this last one, you can control your own problem, you can create your own experiment and make sure that you give enough information so that a classmate could read your problem or your experiment, and a classmate could then write a hypothesis, an independent variable, a dependent variable, control. Make sure you've got some data of what happened so that your classmate can pick it out. And what we're gonna do is you're gonna write your practice problem in the box below, and then we're gonna exchange our practice problems and see if your partner can pick out your experiment's hypothesis, your variables, your control, and come up with a conclusion. So come up with your own experiment. Do not fill in the part on the bottom, because again, you're going to exchange this with someone and see if your experiment, your scenario, is clear enough that someone could pick out all of these different things for your experiment.